Hi, we meet again. For this video, I will share what are the factors that affect the consolidation process. At the end of this video, you will understand what are the factors that affect the consolidation process based on simulation from spring analogy model. To begin, let me revise back what is consolidation. Consolidation is the mechanical process by which soil changes volume gradually in response to a change in pressure. Settlement is the direct result of reduction of volume of a soil mass. What is spring analogy model? It is the model used to stimulate how the consolidation process happens inside the soil. Figure 1 shows how the model looks like. Table 1 shows the corresponding component used in spring analogy model. In the table, two columns shows the representation of soil mass with the equivalent mechanical model. At the first column in soil mass and the second column is the equivalent mechanical model. So, for soil, it is represented by the spring inside the model. Saturated voids are represented by the water. Porosity N is represented by the volume of cylinder. Permeability is represented by the opening of the valve, and the excess pore water pressure is stimulated by the pressure gauge record. Now, let me explain how the model simulates the consolidation process. The explanation will be divided into three stages. The first stage is at equilibrium stage. This situation is analogous to the situation where a soil layer is at equilibrium with the weight of all soil layer, we call it as overburden, is above it. A pressure gauge is connected to the cylinder and it shows the hydrostatic pressure U0 at this particular location. At this stage, piston P is loaded vertically and compressed. A spring inside the chamber which is filled with water. The second figure simulates what happened during the process of consolidation. At this stage, the cylinder is loaded by an N additional load increment delta stress. At the start of the test, let us assume that the valve is initially closed. Upon the application of the load, the pressure is immediately transferred to the water inside the cylinder. Since the water is relatively incompressible and the valve is shut, so no water can flow out from the cylinder and reflected that no deformation of the piston. And the pressure gauge reads as delta U equals to delta stress. The pore water pressure delta U is called an excess hydrostatic pressure because it is in excess of the original hydrostatic pressure U0. To simulate fine-grained cohesive soil with its low permeability, the valve is opened slightly to allow the water flow out slowly, leave the cylinder under the initial excess pore, which is delta U. With time, as the water flows out slowly, the water pressure decreases and the load gradually and the delta stress is transferred to the spring, which compresses under the load. For the final process, when the consolidation is almost complete, no water is squeezed out. The spring is in new equilibrium with the loads, which is delta stress plus vertical stress, and the pore water pressure is again in hydrostatic pressure, meaning to say delta U is towards 0. Okay. For this final process, the soil is at equilibrium with no further water is squeezed out of the cylinder. The pore water pressure is again hydrostatic and the spring is in new equilibrium with the load vertical stress plus delta stress. Hence, for the conclusion, it can be deduced that the factors that affecting consolidation based on spring analogy model are three. The first one is the permeability or K of the soil. So this is simulated by the opening of the valve. The second one is the stress history of the soil. It is simulated by the rigidity of the spring, and the last one is the amount of load imposed simulated by the delta stress on the piston. With that, we have arrived to the end of this video. I hope that everybody understands what are the factors affecting consolidation in soil. See you again for the next video. Bye.